Hey everybody, this is Rick. We moved into this house 5 years ago. Every time this heat pump air conditioner would kick in, the lights inside the house would dim. They dim significantly, and I just never liked it. This is a 4-ton unit. There used to be one just next to it that looked exactly the same. It was a 3-ton unit. It finally broke, and that is also a 3-ton unit now. But I'm looking into doing my research as what's going on here, and that's what I'm going to cover today. I want to stress again, I am not an electrician. I am not an HVAC technician. I'm just a guy that knows how to figure stuff out, and I want to pass this information on to you. And the main reason I'm doing this video is because the guts of mine that I'll show you in a minute, when I was researching how to install this starter that I'm going to install, I didn't see anything that looked like mine. So the whole reason of doing this is so if anybody has a unit that looks like this, hopefully I can lead some guidance. I'm trying to keep this video a little shorter, so this might get a little choppy, so bear with me. This is a big house. There are two 200 amp each service entrances, circuit breaker panels is what most people are going to call it. So I've got a massive amount of power coming into this house, and I can't figure out any reason why the lights are dimming, especially when I'm on utility power. Talked to electricians, and some of them are telling me that's just how it is. Some houses just don't do that. Some houses just do that. We don't know why. The thing that drove me to finally look into fixing this was this. We have a 20 kilowatt natural gas generator that runs the whole house. It's got all the appropriate transfer switches and circuitry. And even if I turn every other high demand item off, every other air conditioner is turned off, we don't have anything electric like hot water heaters, stove, nothing. That's all natural gas. So no big main current draws. And when one of those compressors kicks in from the air conditioner, this thing bogs down so bad you can just hear it. It goes, comes back up. If you lose power and it just comes back, electronics in your house wise, they're okay. The thing that will kill the electronics in your house is what's called a brownout. You have this thing running, power's at its normal level, and all of a sudden that heat pump kicks in, and it has such a big load on this thing that this can't handle it for a moment, and it goes, and the voltage really drops and comes back up. That is what's killing all the electronics in my house. I know there's a governor on here that, just like on a gasoline engine, on your lawnmowers, that when it senses a high load, the governor kicks in and gives it more fuel to bump the RPMs back up. I checked all that out. All that is working perfectly. And it got to the point, I finally got to the right person at the right time, and I called the HVAC tech from the company that installed this 20 years ago, and he had me do one thing. He asked me, what are the lock rotor amps, LRA, of this unit? And I know what the lock rotor amps are. That's when this thing kicks in. Not only does the fan kick in, which draws some power, but the compressor that does all the refrigeration, that takes a massive amount of power. So if you look at the label, and you can see right here, lock rotor amps 137. That is ridiculous amount of amperage. And the way he explained it is, he said, imagine now when this thing kicks in, it's drawing 137 amps. It's connected to one of your electrical service entrances. That service entrance is only rated for 200 amps. So this is taking and asking for a ridiculous amount of amperage in one big spike like that, and it just can't handle it. No matter what you do, even your house main lights dimming is because that 200 amp panel in your house just can't handle it, and that's fine. Everything's wired right, your house is sized right, but that's my problem. And again, when this thing kicks in and I'm on the generator, which cannot even handle anywhere near that amount, it's even worse. So let me dig into this and I'll show you what I'm gonna do. So when it comes to helping with that initial jolt, there is hard starters and now there's soft starters. A hard starter basically looks like an extra large capacitor that you connect in line, and it helps give an initial jolt of voltage when that compressor kicks in. I didn't see a hard start system in here because I'm looking for a round capacitor. So I did my research and I found this soft start system. This is by Micro-Air. It's called the EasyStart Flex. The Flex is their latest and greatest. It used to be you had to size whichever one you purchased, whether you had a 4-ton unit or a 3-ton unit or a 2-ton unit. Now this does it all. You can connect this to the compressor and it'll automatically sense what it needs, and this radically reduces the amperage that this thing draws when it first starts up. I'm going to tell you later on where I bought this and why I bought it from that company. And again, what this actually does is it'll first turn on the fan, which in this case draws 5 amps. So when the compressor kicks in, that's already being used. That's not a big draw on there. But then this brings the compressor up with a lot less amperage. And it actually is going to test itself, restart itself quite a few times, and it's going to figure out how much current it needs to start the compressor safely, but yet not do it excessively. And this is a matter of connecting 4 wires. And again, on most of your systems, you're going to have a very, very basic, clean setup. I will refer you to the company that I used YouTube channel. Their video was the best one I saw for setting up one of those units. It is so simple and so easy. It takes all the guesswork out of it. But for my system, this is quite a mess compared to what I've seen online, but let me back up for a minute. The way you test how much amperage these things are drawing is with a clamp meter. But an everyday clamp meter won't work. They'll average everything out. So you need one that has inrush. This model has inrush. So we turn it on to amperage. It is set on lower amperage, only up to 60 amps, so I'm going to change that range. Now it's on 600 amps, this thing will handle, and I'm going to press the inrush, and now I'm set. Inrush is set. So what you do, first time I'm going to clamp this on the main power coming into the entire unit. So this one will include also the fan. So I've clamped onto the main contactor. This is where all power comes into the unit. So this time it's going to measure the amperage it draws when the whole thing starts, including the compressor and the fan. And you'll also get to notice how loud this is. .5 amps, right? What the label says of 137. That's a ridiculous amount of current to ask an entrance panel into the house to take. All right, this will be the important one. This is the one that is hooked up to the hot wire, one of the hot wires on the compressor, and only the compressor. So when I start it this time, this is how much current it takes to start just that compressor. There you can see 131 amps. Storm's coming. It's time for me to get inside. Yes, all my grass is ugly because I have a lot of Bermuda mixed in with fescue, and I am in the process of killing it all to redo the whole thing. Here is the wiring box for my unit. All the time I was looking up YouTube videos about this system in general, I didn't see anybody's wiring box that had all these extra components. The people that make this, again, is Micro-Air. When I went to the Micro-Air website, they have a generic diagram, and they also have very unit specific diagrams. This is a Rheem system, and they actually had a diagram for a Rheem system. Here's the wiring diagram that's part of the lid on this unit, and everything really matches. They really did a great job on the Micro-Air website. I printed this off and I cut this off, but this tells you what to connect, exactly what to do, what to disconnect. Awesome. So I really think I have a handle on it, but I'm still not seeing things like this. So I reached out to Hutch Mountain. Hutch Mountain is the one video I saw online that really did a good job explaining the very basics, making this very, very simple. I sent them an email, I sent them photos of everything I've got, and I said, do I have this right? Am I ready to go? The guy says, can I phone chat with you? I said, sure. Jesse from Mountain Air called me within 5 minutes. We did a video chat, and that was awesome. That's why I'm going to recommend you buy your unit from Mountain Air. I've never had customer service like that. But in my system, of course, this is the contactor. When we talked about a hard start relay that looks like it's just a really big capacitor, that's not what I'm seeing here. This is a relay and a capacitor. In 2002, if you had a big unit, these two components make up what they called in the day their hard start. It's an extra jolt, goes to the compressor to give it a start. And then this guy that's hanging over here that's just kind of loose and hanging around goes to the fan wiring. It's another capacitor. It goes to the fan terminal on there. And Jesse told me, just leave this. Told me exactly what to disconnect. I'm going to disconnect one wire off of my run capacitor. I know where the other wires all go, and we will get to that in a little bit. I've got this mounted on the inside. Yes, it's a waterproof enclosure. If I could get it out of the rain, to me, that's even better. And again, Jesse at Hutch Mountain said absolutely mount it inside. So next thing to do will be get this wired up, and let's get running. All right, weather would not let me finish yesterday, so this morning I have all of these hard start wires are now disconnected. Everything is separated. All of this is removed. The EasyStart is mounted. It only has 4 wires. The black wire comes up here to the contactor where the other black wire is on this side of the contactor. The orange wire goes to the Rheem terminal on the run capacitor, and the red wire that's coming from the contactor connects with this white wire that's on the EasyStart through these Wago connectors that you simply strip the wire, insert them, and press them tight. The rest of that wire that goes to the compressor connects to this brown wire from the EasyStart and all clamped down. And that is all per the directions there and from Jesse at Hutch Mountain. So let's go fire this up. Just a reminder to please click on the thumbs up button at the bottom of the screen, and also the subscribe button. That helps other people to find the video that you're currently watching. And if you click on the R down by the Rick's Tid-Bits, you'll find I have a whole lot more helpful and unique videos that you might find interesting. Okay, first startup. What this is going to do is when this first turns on, thermostat calls for cooling, contactor will energize, the fan will kick in. This box is now controlling how much amperage current this compressor is allowed to use. There's a computer program in here that's going to Over the next 5 times that you start the unit, it's going to determine exactly how much amperage it needs to start that compressor without giving that full 131 amps that the compressor used to get in the past. All of this can be seen using the app on your phone. I can't show you the app because that's the phone I'm using to record this. The photos I add in the following segments are going to be screenshots of the actual EasyStart app, what the actual EasyStart is reading. First start is 71 amps. That's almost half of what it used to draw. All right, this will be the second start. And I'm waiting 5 minutes in between for everything to settle down like normal. I am not just pulling the quick disconnect over there. .5. Fourth start. And the number on the top is the running amps. It took 49 amps to start it, but after it started, it is using 15 amps of current just to run. Fifth run. So all of those have been on the red wire, which is one of the 220 volt wires. So it shouldn't make any difference, but I just wanted to check it against the black wire. So this will be the sixth start. All right, what a difference. The last reading on the black wire was significantly lower than the readings I had been getting on the red wire. But again, that's my amp probe, that's my amp clamp meter. All of the readings directly from the EasyStart itself were reading around 41 amps after the first big draw. So to go from 131 instant bam lock rotor amps to somewhere in the range of 41, 42, that is pretty doggone awesome. I am anxious to try this tonight on utility power, and eventually I will turn utility power off, disconnect it, and see how this runs on the generator. And in the meantime, I'm getting a second one and installing it on that one because the lock rotor amps on that brand new unit is 81. And if you all stop watching from here, thank you for watching. I hope this helps you. That's the whole reason I do it. I know I've made a mistake and quoted the wrong company a few times, but it is Hutch Mountain is where I bought them from, and they're customer service cannot be beat these days. God bless. Have a great day. This is a brand new unit. It is a 3-ton unit. It was installed just 11 months ago. And the lock rotor amps on this one is 83.1. So the first video is going to be of the lock rotor amps when the entire system kicks in. And then after that, I'm going to show a photo from when I have it connected to just the compressor. .4 power coming, amperage being drawn off the entire system. Once again, I don't like mounting things outside in the weather if I can help it, and especially here because the drip line from my roof comes right here and pounds this, and if I mounted it on the back it would get pounded with rain. So I mounted it inside. I used the black grommet that they supplied. It's installed in here and looking straight down. The bulk of it is completely out of the weather. I'm liking that. All right, once again, the EasyStart is connected. This is going to be the first time we start on the EasyStart. It goes through a learn process of you start and turn it off and start it again 5 times. And it learns just how much current to give that compressor to start without giving it that massive blast. The first one is going to be a little on the higher side than the ones after that. And the fan will be the first thing kicking in. .1 amps. That's a tremendous reduction right off the bat, and I will attach some screenshots of what the actual app is reading. Second start. This will be the third start, and this is how neatly it all tucked in there together. Fourth start. Fifth start. The app is telling me I went from 77 amp startup to down to, I'm averaging about 28. That's amazing. This thing is awesome, and that's really going to help when I kick on the generator, but it's also going to help extend the life of this guy. All right, there's mine all tucked away, nice, kind of dry as I can make it. And the connection of this is extremely simple. It's 4 wires. You go to the Micro-Air website, look up your model number. If it's a newer one, chances are it's going to be very open and basic like this. Follow the diagram they have. And if you want a general diagram, that's universal for a lot of them, but you need to look up your own specific one. But again, I highly recommend going to and buying this from Hutch Mountain. Their customer service was absolutely amazing. All right, I have turned utility power off. I am on the generator. I'm going to turn on first that 23-year-old 4-ton unit that used to draw 137 amps with the EasyStart. It's now drawing about 40. The two lights in the ceiling straight ahead are what used to dim significantly, and also I'm going to be listening to the generator to see how bad it bogs down compared to how bad it used to bog down. Wow, that's amazing. That generator used to drop down so low and the lights used to flicker so terribly. That's just outright amazing. All right, next thing, I'm gonna go upstairs and engage the brand new 3-ton unit that used to draw 81 amps, is now drawing about 28 amps. Wow, again, that is shocking compared to how it used to work. Very well worth it. My goodness, now I can run both air conditioners on the soft start system. Amazing. I hope this video helps you. Again, if it does, please click the thumbs up, like, and the subscribe button, and thank you for watching. Please check out all my other videos. I've got a lot of other helpful and unique videos out there. God bless. Have a great day.